this video, we're going to talk about one of the additional topics in the appendix of the textbook in section 8.7. It's A.7. We're going to express exponential expressions containing positive rational exponents with a numerator of 1 in radical form. And then we're going to simplify if possible. So we're going to do from A.7 numbers 3, 5, 7, 9, 13, 15, and 11 I missed. Okay. So let's go ahead and get started here. First example is going to be 125 to the 1/3 power. We're going to use the property that x to the 1 over n is equal to the nth root of x. So I'm going to write that as the cube root of 125. What I'm going to try and do is I'm going to write 125 as a perfect cube, if I can, and then the cube root and the cubed will make each other go away. So 125 is 5 times 25, which is 5 times 5. So that means 125 is 5 cubed. So the cube root of 5 cubed is 5, because the nth root of x to the n is always x. Assuming that x is a positive number here, which we are assuming. Now we want to look at the 4th root of 1 over 81. We're going to use a rule here that says the nth root of a over b is equal to the nth root of a divided by the nth root of b. And we're going to use another rule that says that the nth root of 1 is always 1. So now I need to write 81 as something to the 4th power. That's 1 over the 4th root of 3 to the 4th. So that's going to be 1/3. Go ahead and erase some of these notes here. The main point of this section is to show you that roots are just fractional exponents, or what we call rational exponents. Now I have 121 to the 1/2 power, which is going to be, if I want to write something to the 1/2 power, I write it as a square root. I don't write any index on it. It's assumed to be a 2 if I don't write any other index. 121 is 11 times 11, or 11 squared. And be careful with this next one. It's like number 9. It says 4m to the 1/2 power. The 1/2 is only on the m. It's not on the 4. There's a multiplication symbol right here that separates us, and the exponent is only on that factor of m. So this is going to be 4 times the square root of m, and I can't simplify that at all because I don't know what m is. Come back to number 11 in a second. Number 13 is, this is a problem like 13, like that. So I need to think of the cube root of -27. So this is the same as the cube root of -1 times the cube root of 27. -1 can be written as -1 times -1 times -1, or -1 cubed. So I'm going to write that as -1 cubed, and the cube root and the cubed will make each other go away. So there's a -1 as a multiplier here. Cube root of 27 is 3 times 9, which is 3 times 3. So that's 3 cubed. -1 times 3 is a -3. So when I have a negative number inside of an odd root like this, the negative is going to be able to come out front, and the positive part here will stay inside. I cannot take a negative outside of an even root like a square root or a fourth root or something like that. All right. Now I have number, something like number 15, -81 to the 1/4, and the 1/4 is only on the 81. The negative is out front of the whole thing. So this is the same thing as -4th root of 81. And I think we took the 4th root of 81 earlier. Let's do it again. This is 3 to the 4th. This is -4th root of 3 to the 4th. It's -3. That's my answer. I have one more problem to work with you that's down here. So we're going to put some x's inside of a square root this time, and this is going to give me the opportunity to tell you about a particular rule. Now I'm going to read the instructions the way that they say. It says use radical notation to write the expression, simplify if possible. The instructions say assume that all variables represent non-negative quantities. I'm not going to do that because I want to tell you about a rule here. So if we were not told to assume that all variables were non-negative quantities, meaning that they were zero or positive numbers, then we would have to know that the square root of x squared is equal to the absolute value of x. That's going to be very important for you to know that the square root of x squared is not equal to x. It's equal to the absolute value of x when you get to pre-calculus and when you get to calculus. So this book does not like to make you know that and write answers that way, but your instructor might give you some problems where you need to know this and write answers with absolute value signs. So anytime that I have an even exponent on the inside of a even root and it comes outside with an odd exponent, then I need to have absolute value bars around it. But we'll get some examples of that when we get to pre-calculus and calculus. I just want to introduce it here, but because the absolute value function is equal to x, if x is greater than or equal to 0 and it's equal to negative x, if x is less than 0, it's a graph that looks like this. It's got two pieces to it. So it's the line y equals x over here on the right, and it's the line y equals negative x over here on the left. They're telling us only deal with this right-hand piece of the graph so that when I take the square root, I want to get x for an answer. That's what the instructions are telling me. So I've got a new rule here that if I have a times b to the nth power, this is a to the n times b to the n. I guess that's not really a new rule because I told you that a product inside of a root is a product of the roots. So I'm doing the same thing here. So this is going to be square root of 64 times x squared, which is going to be the square root of 64 times the square root of x squared. We know that the answer to that is 8 because 64 is a perfect square. And if we had not been given the instructions that we were dealing with non-negative parts, we would have to put the absolute value of x here. But because they told us that x was non-negative, we can just go ahead and call that x. That's why we saved number 11 for last. I wanted to go ahead and talk about this stuff over here. Hopefully you understood all that in this problem because of the instructions that we were given that x was non-negative, meaning that it's greater than or equal to 0. We can just go ahead and write the square root of x squared as x. If you're not given that instruction in a problem, you can't assume that, and you would have to write the absolute value of x for your answer. All right. We will come back next time and talk about something else. Let's see, what will we talk about next time? We will talk about same kind of thing, only the numerator is not going to be equal to 1. So we'll have an exponent left inside of the square root when we come back next time. Okay, see you for the next video.